Hi, welcome back, folks. Oh, and I forgot to say, Tommy, well done. Because he's a probability of 93% of winning 8 or more games. So, I should have said that to him. He's such a guy. So, what we're going to look at here is, again, stick with Tommy, such a great lad. We're going to change the question a little bit more. So, here is, hopefully, my new question. Right. Just giving you time to just soak that up. So here, what's the probability that Tommy wins less than 8 games? Well, I never put it in there, but we're sticking with the total of 10. And the key phrase here is less than. Right? Less than 8 games. So, what does that actually mean to win less than 8 games? We know the total's 10. Okay? So, here, just sticking with our notation, W for 1, 8, and that's fixed. And that little symbol there, pointing away from the 8 to the left, that little kind of arrowhead, what's that, a nose? That means less than 8. So have a wee think. Someone's might be shouting out, we could win 8. No, you can't win 8, because it says less than 8. We could win 7, could win 6, 5, 4, 3, 2, 1. Are you fine with that? But what if Tommy's having a bad day and he doesn't win any games? It's highly improbable, but it could happen, folks. So, are we going to take this on another page? Let's see. Point up a wee bit here. So, as we said, Tommy's having a bad day. So we need to calculate that probability. I could win 0. Oof. 1, 2, 3, 4, 5, 6, 7. Don't include the 8. Goodness cribbins. That would look like that there. That's an awful lot of calculations. You know how many calculations you've got actually in total there? Pick the top 1, 2, 3, 4, 5, 6, 7. In fact, I'll go back to the other page. See if it's in that other page. Right, you can see counting from 1 to 7, that is 7, but we need to include 0. So there's actually 8 probabilities we're calculating here. Right, and the page actually started growing because I had that many calculations. That is going to take you absolutely ages. Oh, what's that? Stop. No, the video's not stopping. You're stopping. And there's just too much going on there. So we need to see if we get a way around this. So what we're saying there, we'll use the fact, right, that the sum of all individual probabilities for each outcome, we data them there. But we're going to concentrate our focus on them all. They always add up to give you 1. Like on the head and tails, there was 2 of them, but they always added up to give you 1. On the dice or die, when we added up the 6 probabilities of 1, 6 for each of them, we always get 1. So here, probabilities are not always the same here, but they always add up to give you 1. So there's the magic number, 1. So, I've had to write small here so I could fit them all in. So I'm coming away from the question initially. So, he could win 0 games or he could win 10 games, and I've got everything in between there. So that's what I'm putting down here. So like I said, I'm coming away from the question initially, but the sum of those, because that's all the possible outcomes, they must give me one here. Right. In a little exercise I've written, I've managed to squeeze that all in one go, I hope. Right, but our question involved winning less than 8. And on the previous page, you saw what those were. So I've just highlighted them there. Okay. So now we're going back to the question. So I'm replacing the highlighted part on the top, the probability is going from 0 up to and including 7. So I am just renaming them as probability of winning less than 8. Same thing. Right? We've encapsulated them there. It's like putting things into a suitcase, and once you've closed it, it's just the one suitcase. We don't care. So that line is actually now, and like I say, that's what we want to calculate. Right. So now I brought down the other 3 probabilities to make up to a total of 1. Okay. I just want the thing in the yellow and red there, probability of winning less than 8. So I'll need to get rid of those other probabilities. So I've just, with the magic of algebra, they're all positive there. So when I take them across, I subtract them. Okay, but I've just put them in some rectangular brackets to keep them safe, and I need to subtract. Technically, I'm subtracting to both sides. Okay, so I've done that there. Go back over your algebra, folks. We're not teaching algebra here. Right. So does that help us here? Well, 1, that's just a number. So really, to calculate the probability of less than 8, I go to the right-hand side in the rectangular brackets, and I only need to calculate 3 individual probabilities. That there. Okay. Right. We had already calculated that. Okay, that's why we're sticking with the Tommy theme. One question feeds into the next. So we can explain different things that are happening here. So we've already calculated the probability of Tommy winning 8 or more games. That's what the wee symbol means. W is greater than or equal to 8. We've done that. Okay. So let's say that was the answer to the last question. Right. So we have done that, folks. Right. That's if you were there. So just going back to that. Right. Probability is 1 and less than 8. That's going to be 1 minus. Remember the 93% of the 0.92981? Already done that. And fire that into the calculator, and you get that answer there. 007. Okay. In little bits. And again, for consistency here, folks, I've just been working away 5 decimal places. For whatever reason. Because it's my game. Right. So, what does that mean? So that means Tommy, his probability, 0.07019 of winning less than 8 games from 10. So that's approximately 7%. And it's such a low probability. It's because Tommy is so good. Right. I think I'm going to leave that there. But that last question that we looked at, it's using something that's known as a complement rule. And we go back to the notes, I explain that a wee bit more. But you saw that in the last video, that when we rolled the dice, getting the 1 face up, probability was 1/6. But the probability of not getting a 1 was 5/6. So the 5/6 was a complement, okay, of that. Because all the probabilities add up to give you 1. And I'm going to leave that there, folks. And I'm going to stop that video. And I think that's Tommy's done his job. So we looked at exactly winning 8 games. We then went on to look at winning 8 or more games. That involved the 3 probabilities. Then we went on to the difficult one of winning less games. So initially it looked as if we had to calculate 8 probabilities, but we get around that by using that thing called the complement rule. Right, so I'm going to leave that there, and then I'm going to come back, maybe a sciencey type question. Right, I'll see you later. Bye.